Hello everyone, in this video I am going to explain binary tree traversal. Here there are the three methods to traverse a binary tree. These are pre-order traversal, in-order traversal, and third one is the post-order traversal. So here I am going to explain only the pre-order traversal. In this traversal, what exactly the things? Here the tree is over here. So this is the way. In this way, the tree here I am taking a tree just for an example to explain what exactly the way to traverse this thing. So these are the tree over there, and I am taking the node here A, B, C, D, E, F, G, H, I, J, and K. So here I am explaining only pre-order traversal. So I am going to remove all these three. So in this traversal, what exactly the approach we are using? So here, if I'll go to traverse, so you know, okay, for the tree, always we can access from the root. That the is root. So in that case, from here. So what exactly the pre-order? In case of pre-order, what exactly we always traverse in the way of, that is V L R. So we will like a vertex, or here you can say root. This L, that is the left child, and this one is the right child. Or you can also say like a tree, left subtree, right subtree, in that way. So accordingly pre-order. So first of all I'll follow the vertex. So in that case, from here I'll start. So the things are, first vertex is that A. So the sequence I am writing here, pre-order sequence. So here A, then once again, because that is the vertex and this part is the, this is the left and this one is the right. So that is like a left subtree, right subtree. You can also say like a child or subtree, and this is also like a subtree. So A. After this V, I'll go for the L. So in the L, I'm not getting a single child. Here it is the complete subtree. So in that case, once again, the same process I'll follow. So for this subtree, this is B is the vertex. So once again, that B. And after this B, once again, if I'll come down for the left of this B, so in that case, this is the vertex. So that is D. And after that, I'll come to the left once again. So left, that is over here. So that is the vertex once again, H. After that there is nothing, so that this H. So for this subtree, for in this subtree, this vertex, and then this is the left, and now it is right. So I'll write I. So right, and after coming upward, so for this subtree, this one is the left subtree, that is already written. So this is your root, that is there, and the right part is there. So in the right, once again, that is the subtree. So what exactly will happen? It will take the vertex. So once again vertex, and then it will go for the left. So the left is J. So that is vertex and left, that is completely filled. Now it will go to the right side. So once again in the right, this is also a subtree. So it will go for the vertex, so C, and after that it will come to the left. In the left, that is F. And if you will go in the right side, once again it is the like a subtree. So for this subtree, like a vertex, and then it will go for the K. So in that way over there. So what exactly the sequence is, you can see here, this A root, and after that this entire tree recursively in order manner I have traversed. So here I am writing, it is like a V. This part is up to J, that is L, and this part is like a R. So that is the pre-order traversal of a tree. Clear? So now I'll try to make a, or write a pseudo code for this in order traversal. Here you can see the things here repeatedly. This root, for this subtree this is root, for this subtree this is the root. So after coming over here, so that is the left and right. So root, left, right, and now it is the complete. Left is over there, root is already written, left is there. So I'll go in the right side. Once again it is like a root. So root, and then that is the left, right is nothing, so leave that one. and that is completely the left child or the left subtree of this A, and in that side I'll come. So in that case, right, once again repeatedly I'll do the things of the VLR. So then C, then once again left, so left F, right side, so repeatedly that will also go in the vertex and left, so G and K, that is the sequence. Now I'm trying to write a pseudo code for that thing. So what exactly the way to write the pseudo code for the pre-order? Here I'm assuming key you know little bit about the linked list representation of a tree. Here if you want to represent, so what exactly the structure of node? So node of a tree that have the three fields. Here three fields will be there. So three fields like in this way. So that is the left child address. So that's why that is left pointer, and that is the right child address that will hold. So that is the right pointer that is there, and then this part is the data part, and this will be for each and every node. If I want to represent any node like in this way, so for A if I'll write, so A will be here in the data part, and this will have the address of V. So it will have address of node B, and here it will have the address of node C. So that is the overall structure, and in the similar way you can see the things where there is no left or right side, so in that case you will write null. So that is the representation. Now using this representation I am trying to write a function or a C function simply to traverse this tree in a pre-order manner. So what exactly the things are there? So I'll try, because there are the three fields. So the node structure will be, if I'll create the node, so if we want to check the things in the node, so in that case there will be the data, then left pointer, so there is the right pointer, that is the node. Here I am creating once again in this way, that is data, this one is left, this one is the right pointer, this one is also pointer. Clear? So that is their end node. So this is overall fields that a node requires. So in that case I'll try to create a C structure. Here I am trying to create a C structure for these fields. So I'm writing here struct. Here I'm assuming you know to write a structure for any linked list representation or for any node. So that is, I'm not going to explain directly. I'm writing the things struct. Here I'm giving the name like a node. So node, what exactly required data? Here data is in the character type, so I'm taking char data, and these are the pointer of this struct type. So here struct node star left and struct node star right. That is the overall structure code of this thing. Now I'm here the struct node is now data type. I do not want to repeat that struct node again and again, so here I'm writing type def, then struct node. Here I'm putting node. So this node, now I have given the renaming of this struct node as node. So now node is a data type of in this way of this specific node type. So directly I can use like an integer float, that is the data type over there of the integer type. So directly you can use. So now I'll use this node, and using this node only, I'll try to traverse this tree. So I'm writing the pseudo code for the same thing. So this representation is over there, so I'm removing this one and trying to write a pre-order traversal of a tree. So this is also I'm removing, this tree is over here, this. So pre-order traversal, so I'm writing a pre traversal. that is for the pre-order traversal. This is the name of function, and as we know, because I want to give the address of this node as a uh, address of this node to this parameter, so obviously it is of the data type, so I'll define a pointer of this node type what I have defined over there, and that is I'm pointing like a any one of the element like a root. I'm writing here root in this way. So what exactly will happen? So in that case, and the returning, I'm not going to return anything here. I'm trying to print that data over there overall in this way. So I'm giving the return type is also void. Now I'm trying to write the code. So the first condition I'll check if this root not equal to null. If it is not there, so what exactly first thing first I have to print the data. So it will go to print that root data. Here you can use printf %d. I'm not using, so otherwise you want, I can write the things also in the way printf %d. So root data, that will be there, and then after that you are recursively call this function just to get the this thing also recursively in the same manner. So after this this will be over here, and this if, so this if I'll write this way. So if from here you can write, and this thing taking after if, that root is that after this if. So I'm writing the if body here. So printf this, and then after this I'll come to the left side, because I told you it is of the part of like a VLR. So vertex is there, then the left side I'll go, and repeatedly I'll do the things. So once again I'll call this function recursively. So in that case I'll write pre-traversal. So that is there. So I'll write pre-traversal. Now I'll not use root. What exactly I'll use? Root child. Which one child? That is left. So I'll write root left, and that is also a type of this 3 fields node. And after this, after performing this thing, once again it will go to the right side. So it will be like a pre-traversal root right. Now this if body will close, and then this function will also close. So this is the overall pseudo code just to traverse in a recursive manner for a pre-order traversal. Here I am assuming you know the recursive function call. Otherwise I'll try to little bit explain this thing for this one. So suppose what exactly the sequence, you can check the things here. I am explaining once again, and then suppose what exactly will happen if root not equal to null. So root here I'm passing, so starting here the this one is like a root. So whenever I'll call this function, I'll pass this a. So what exactly will happen? It will check if root not equal to null. So root is not null. So what exactly will happen? Printf %d data. Here I'm passing the address of this root node a. So what exactly will happen? Printf a. So it will first print this a. That data is a. After that what will happen? It will go in the pre-order traversal root left. So this a left here. So it is calling itself. So once again what will happen? It will go to the top and check whether root is equal to null, root not equal to null, root not equal to null. So what will happen? Once again it will print the print data. So it will print b again. And after that what will happen? After this printing it will go in the root left. So it will come to the first it was there, then it will come to the over here. So root will once again, then this root will come over here after printing. Then once again it will check root left. If it is not null, obviously not null, so it will go to the root left. Now root is over here, so once again repeat this thing and it will go to the d. And after this once again it will check whether it is not null, so it will come to the h. So now root is over here, so these will be removed. Gradually it will come to the left side. Now root is over here, so it will print h, and whether root is not equal to null, so h is not null, root data printed. Once again it will go to the root left. When it will go to the root left, so here in the left, because if you will see in the case of h, this will I'm creating this h node, so h will have the data and there is no child, so it is null. So if root not equal to null, this will not satisfy. So what will happen? So in that case, that will be terminated over here in the left side. Now what exactly will happen for this d? It has been called. So in that case, it will go just to check the pre-order traversal root right. So it will come to the root there. So it will come to the right. The right side is I. So it will go to print I here. Once again, it is I. So I. Then after this I, once again it will go to the on the top, whether it is null, not null, it will, so it is printed over there. After I, it will go once again I left. So in that case, I left is equal to null. So once again it will go to the I right. Once again I right is null. So this will go to the D level. So that is completely LVR. Now from this level it will go to the top level. Here the left part is completed, so it will go to the right side. Once again it will go for the, so these two have been completed, so it will go to the root right. In the right, so data will be printed once again, that will be E, and then it will go to root left. In the root left, that is J, so it will go and check root data. J is not null, so J will be there. Then it will come to the left side, it is null. So once again it will go back and check in the right hand side. In the right there is nothing. So now this is completely this traversal is completed. So it will go to the top level. So now it is looking for the right side. In the right side once again, so root right. So in the case of root right, it will check whether this C will be there. Now the root will be over here. So this root will go and check whether root is equal to null. It is not null. So what exactly will happen? This C will be printed, and after that it will go for the root left. Once again, so root left. So root will be over here now, and check whether root is equal to null. No, it is not null. So first data will be printed. So data will be printed. Again it will go back. Now root is null. So once again it will go back to this root, and then it will go to the root right. So root right, this part is there. So now root will be, this will be gone, this will be gone. Root will be here. So check whether it is null. No, it is not null. So it will print G, and after that it will check root left. This root left. So root will come over here. Root will print K. Once again, repeatedly for the K, it will go and check whether root is equal to root left is equal to null. Yeah, it is null. So it will go for the once again the root back over there, and it will check whether root right is there. There is no root right, so that will also be terminated over there. So this is the overall traversal of a tree in a pre-order manner. I have written whatever I have written over here, that also I have tried to traverse using this pseudocode. Now you can see the things if you want to see in a pictorial manner how it works. So what exactly the things are there here. See what exactly happened. So I'm removing this thing here. I'll try to write what exactly happened in this one. Here I'm assuming you know the recursion function, but still if you do not know, I'll try to little bit to explain the things in which way it is going. So first of all, what exactly will happen if I'll call this function anywhere? So it will call first pre-traversal A, because I am passing here pre-traversal A. So that is there. What exactly it will call? It will print. So print A, that will there. Then after I'm here try to simply make a stack of the things in which way it is working. After this print A, so if it is not null, so it is not null, print A, print, so printed A. Then pre-order traversal root left. So once again it is calling, this function is calling here, this one is this is calling here pre-traversal B. Clear? So let's see what exactly the data is there. This A is there. Now pre-order traversal B, it is called inside. This function has called. This has not been terminated. That's why I have taken the space simply to show if this function has called this one. So inside B, what exactly will happen? It will, once again it will go on the top and check whether root is not equal to null, not null. Print root data. So now B is the true. So it will go and print B. Again, what will happen? It will go. So print B. Then after this thing, it will go pre-traversal root left. So pre-traversal again it will call in this manner. So this is over there. So it is calling. Still A and B is in the process. Now it is calling for the A B left. So what exactly? Pre-order traversal. Pre-traversal. So I'm writing the name of the function. So pre-traversal C. It has called C, and once again it will check whether the no, it is D now, because in the left A B D, so it will call D. Now print D, because D once again it will come to the over here whether root not equal to null, not null. So print D. Now it will print D. Again it will go and check. Then root left. Now root is your D. So what will happen? So root left. So it will go once again. It will call pre traversal H. So again it will go and check. Now your root is H. H is equal to null. So in that case, so here it is called. This is called here. This is so. This is the first function. This is the second function. This one is called third, and this one is called fourth. So in the traversal, pre-order traversal H. So it will check whether H is null. H is not root null. So print H. So it will be printed, and after that, what will happen? So it will go to the in the similar manner. Again, it will process the things. It will go not null. So H is printed. It will go to the left. So pre-traversal H left. Now H left. This condition is not satisfied. So it will be now it will start to come back. So print H, that is there. Now this function is completed because it will go for the H left. Next, after printing this H here, if the root is your H, the H data, then it will go to the H left. And once again I am calling. So pre-order traversal H left, pre-order traversal null. So in that case, root not equal to null, not satisfied. So that function will stop over there and then return. So this is there. So this function in this case, it will go back for the pre-traversal left. Now it will go to check whether the pre-traversal, because for the H, what exactly happened? I put data, then in the left, null. So condition fail. Again I'll go to the right, that is also null. So that will fail. So this function is completed. Now this function is completed, but still this D is there. So in that D, what exactly will happen? I have printed D, and the root left, that has been printed, because in the left, that is H, that has worked. So H recursion is over. Now it will look for the root right. So in that case, root right, it will go and check whether what exactly in the right. So I'll call print pre-traversal root right. So pre-traversal. So after this, the fifth function will be called. This is over. So fifth function will call pre-traversal I. That will be here, and you will check whether I is equal to null, not null. So print I. So see, after D and H, that will be I. Clear? Then once again it will go and check after data I left. So I left, in the I left nothing. So it will go to the null, and this condition will not satisfy. So again for this I, it will go to the right side and check whether I right. Once again I right, that is null. So condition will not satisfied. So now D is over. So D part is completely over, because in the D, this part was the left child and this part was like a right child. So it is over. But still after D, this B is working, because these two functions related to this D. So it is over. So now what exactly will happen? It will go for the B. So in that case, B is there. Pre-traversal, so left child, left part of this B is clear. It will go to the right side, because after this left, you have to come to the right. So in that case, this for B, it will call the function. So it will go B right. So B right, what exactly that is there? So that is the E. So what exactly will happen? This sixth function will be called pre-traversal E. So in this pre-traversal E, what exactly will happen? So now E is equal to root over there. So it will check print root data. So E is not null. So it is not null. So it will print E. So it will print E. After printing this E, so you can check that the sequence what I have written, in that way it will come. After print E, so it will go to once again root left. So E left, what exactly that is? In case J, so it will call once again pre-order traversal, that is for J. So in that case, what exactly? Once again it will check whether this root is null. It is not null. So here that will root data. So print J. Then it will go once again after printing J left. In the J left, that is null. So it will come back. After coming back, once again it will go for the J right. J right is already null. So it will go back. That is null. So this code will not execute. But still you can see E is still open. So this left part is terminated. Now it is looking for this one. So it will go for the pre-order root right for this E. So in that case it will go E right. E right is null. So this condition will not satisfy, and that's why for the E right it will not execute. So see the things for up to this B level it is completed. So this B is completed, up to B is completed. So to see the things up to B it is completed. So that is the left part of the things. Still I have to traverse in the same way. So for this root A up to this left part I have decided explained over there in the similar manner, because now you have to go for the right side. So in the right side once again in the similar manner you have to traverse the things, and in that case that will give you the overall sequence what I have written in the. That's all for this video. Thank you for watching it. Kindly subscribe and like the channel to get latest videos and updates. Few more channels are also there in the last to get latest updates in new dimensions and domains. Kindly subscribe and like them as well.